Kip, describe the structure of black hole.
So a black hole has a horizon, which is the surface of the black hole, except it's not a hard surface like the surface of a billiard ball. And it has a singularity at the center, and it is made in the vicinity of the horizon and down to the singularity by warped space and time. The horizon is a very special place. It's the place that has the property that if you fall into a black hole, you pass through the horizon, you don't notice anything special until you try to get back out, and you can't get back out. You're pulled inexorably toward the center. And we know they are there with 99.9% confidence from observations mixed with a little bit of theory. We know that in our own galaxy there are roughly 100 million of these objects that have sizes of about, say, 10 miles or so across, sizes like that. We know that at the center of our galaxy and almost all other large galaxies, there's a huge black hole that has a size more like the distance between the Earth and the Moon.
And the equivalent of mass of how many suns?
Yes, and at the center of the galaxies, masses of 1 million to 1 billion to 10 billion times the mass of the Sun, all contained in this size that is more like a small piece of our solar system. The smaller black holes, the ones that may be 10 miles across, weighing the same as maybe 10 suns. So they're remarkable objects from that point of view. But the thing that has gripped me about black holes, in the same way as black holes grip by their gravity anything that falls in their vicinity, is the fact that a black hole is an object that is made not from matter, but from warped space and warped time.
What does that mean?
Well, so suppose that you were to measure the circumference around a black hole. And so you go marching around and around, and you see that the circumference is 30 miles. And then suppose that you measure the diameter. You would think that diameter ought to be 30 divided by pi, or 10 miles.
Roughly 10.
But no, you measure that diameter, and it is enormously larger than 10 miles. It may be 1,000 miles, it may be 1 million miles. It's unbelievably large. So space is warped. And you might ask me, well, how is it possible that you can have a huge diameter and a small circumference? Don't the laws of Euclidean geometry forbid it? The answer is yes, they do, so Euclidean geometry doesn't apply. It's like you take a child's trampoline, a large rubber sheet, and you put a heavy rock, very dense rock in the center, and it sinks way down. And then you're an ant, but you're a blind ant, so you can't see what's going on, and you march around and measure the circumference around the trampoline, and then you go in and you measure the diameter by marching down and back up around the rock, and the diameter is huge compared to the circumference.
Wow.
It's the same thing. And that is what the black hole is made of. There is no matter in that black hole. It's not a dense object made of very dense matter. There's no matter at all. There was matter in the star that gave birth to the black hole. Long ago, a star like our sun, but somewhat heavier, will have burned its nuclear fuel, can no longer keep itself puffed out by its internal heat. It starts to cool off, and it then implodes. And all of the matter in that star, much more matter than we have in our sun, goes crashing into the center and is destroyed at what we call a singularity at the center, where that rock was on the child's trampoline. All the matter is destroyed. There's nothing left except this warped space and warped time.
Now, most people would think that if we have this 10-mile object like a big bowling ball, if it was possible not to be destroyed and I got there, I could knock on it, it would be solid. But if I passed through that boundary, I wouldn't know the difference.
That's right, you wouldn't know the difference. However, you would know the difference if you tried to come back out. But there's nothing special at the boundary that you can see locally in your vicinity. There's no hard surface. And if you look above yourself, you can still see the universe above your head. They just can't see you. It's a one-way membrane. Light can come in from the universe into the interior, bringing you an image of what's going on in the universe. But you can't send any light back out to your friends outside to tell you what's going on. You pay the ultimate price when you go in, that you can never publish the results of your explorations. Of course, and by the way, you also die. Einstein taught us that mass and energy are the same thing. You can convert them back and forth, okay?
E equals mc
E
squared.
equals mc squared. And so the mass or energy in this black hole is actually not concentrated in the singularity. It's concentrated in the warping of space and time. In the same way as if you take the child's trampoline and you put the rock on it and the rock deforms it, it takes energy to deform it. You have to really push on it to deform it. You've got to put energy in to stretch the rubber. In the same way, as the star gives birth to the black hole, the star does a lot of work as it creates the black hole, as it implodes, and all of the mass and energy of the star in the end goes into the warping of space and the warping of time.